Okay, so there's another terminology here called a geometric series. And what a series is the sum of terms in a sequence. The sum of the first n terms of a series is denoted S sub n. A geometric series is the sum of the terms of that geometric sequence. Okay, so for the example where we had the guy who was eating the chocolate bar, two different ways we can look at it. We could say, what is the total amount of chocolate he eats in the first 3 days? So that would be a series. We'd be combining the, he ate half of it and then a quarter of it and then an eighth of it. You'd add those things together and you'd say that total is the series for the first 3 terms. So you can pick a range. You can say for the first 3, or you might just say from the second day to the fourth day, how much does he eat total? That would be a series as well. Okay, so it's just a sum of a certain number of terms. What we tend to find the most useful in math is talking about where series goes as we go out to infinity. A lot of these series will that we can make will converge on some number. So for example, with the chocolate bar number, like I said before, he's never going to eat that whole chocolate bar, right? He's going to eat half of it, and then he's going to eat half of that, half of that, half of that. He's never actually going to eat the whole thing. But if we were to take that geometric series and extend it out forever and ask, what does it add up to? Well, if you go out to infinity, the idea would be that it would add up to 1. That's the number that we're approaching, right? We're kind of converging on a value, a total of 1 full candy bar being eaten. Okay, so this is kind of the way that some of this notation is going to look like. Given the first term and n number of terms that we want to go through, so like let's say we're trying to do 5 terms, then the series of the first 5 terms added up is going to be the first term minus the first term times the ratio to the 5th power divided by 1 minus the ratio. If we're given the first term and the term that we're looking to get to, then we will have the exact same formula here. We'll just be swapping out this position, A1, with AN. So what they're getting at here is there's 2 ways to get these sums, 2 ways to get these partial sums. When they say partial, that means like in my example, the full sum would be all days out forever. The partial sum would be from one position to another position within your sequence. The sum of a series can be written in shorthand by using sigma notation, which uses Greek uppercase letter S to indicate that you should find a sum. So sigma notation is very, very common in math. This little symbol means that we're finding a sum. So if I stick to my chocolate bar, this would be the sum from the first day to the 6th day. So that would be a partial sum along that geometric series. Okay, so the last value is on top, the first value is on the bottom, and then we put the formula for the series over here. So that's like, the equations that we were generating before goes on the right side. So we say the sum of this equation starting in one place, ending at another. Okay, so for example, in an arithmetic sequence where we were just like a linear equation, we were just every time k gets bigger, we add another 3, right? 3k plus 2. Well, then the sum from the first term to the 6th term is going to be, we take that formula and we put in a 1, we put in a 2, we put in a 3, a 4, a 5, all the way up to a 6, and we add all that stuff together. So our terms 5, 8, 11, up to 20, we add all that stuff together. If we're doing the geometric sequence, okay, like this one, well, this looks like we have a starting value of 5. That's our first term. We have a common ratio of 3. And we want to say what happens when we add up all of the terms from term 1 through term 8. Well, we'll simply put in 1, 2, 3, 4, 5, up to 8 in our position K up here. And that will give us, 5 times 3 is 15, times 3 is 45, so on and so forth. We'll have 8 terms, and we'll add them all up together to get the sum of our geometric series.